Hello everyone, welcome back to NPTEL online certification course on research methodology for planning and architectural studies. So today we'll discuss an important aspect of the entire research methodology, that is on determining the sample size. Wherever your research is based on certain experiment, so sample size is going to be very crucial, that how much sample should be adequate and which is also statistically significant to bring certain conclusion. So in our previous lectures we have discussed various aspects of type of surveys and other thing. Now we are discussing about the sample size determination. So what we are going to learn out of this particular lecture? So what is sample? Why to sample? Why it is required for a study to go for some sort of sample selection? Then also I will show you some sample size calculation, and this is very particular to a participatory approach or study where you go for capturing the user's perception, user's experience. Then this is something that some established calculation that we have. But definitely in all such cases the calculation is based on the minimum sample size required for the study. If you go higher in number, definitely there is no harm, and in sometimes probably you also need to go higher than the minimum size sample because of certain other reasons that we'll discuss in consecutive slides. And then finally we'll summarize the overall importance of this sample size selection, and then we just move ahead with sampling technique for our next discussion. So what exactly is the sample? So if you just look at it, the dictionary meaning of it, the sample is nothing but a small part of the quantity intended to show what the whole is like. So that means it is something like it is just a small subset of a bigger set of data, or you can say the population, the total number of people in a particular region or in a study area, or it may be like the target group. So this is the entire population. So out of that you need to pick up a small subset, that is the sample. But this sample should have all the characteristics and it has the representativeness of the target population. Say I have quoted this example earlier also, like this is very simple and day to day activity that we can observe in our like kitchen, that suppose you are boiling rice. Okay, so in that case that okay, you have to give certain sort of heat and you put your raw rice to the water, and then it will take some time, reach to a boiling point, and after that the rice is cooked. Now whether the rice is cooked or not, for that you don't need to check each and every rice that is there in the boiling water. So you can take up a portion of it, and then probably by smashing it you will understand that how much it is cooked. Similarly, when suppose you are not cooking it in a open vessel, so that probably in that case like how many whistle that you need to make in your pressure cooker. But that is also some sort of experiment that you have done. Based on that, the amount of rice that you are cooking, the amount of water that you are pouring into, and the size of your pressure cooker and the heat that you are giving up. So in this case definitely if you provide more heat, so probably it will take less time. If you provide very slow heat, it will take longer time. So the sample size and other thing will also depend on other aspect as well, that what is your purpose, whether in that case you need to capture the larger portion heat, the testing should be done in frequent interval, or maybe it is something that you can take up a sample and that is good enough, you don't need to further investigate about the acceptability of that particular subset. Now another example that I have quoted earlier, like say for example if you want to just understand that whether in a box of apple, that whether the apple is in good condition or not. So for that one option is that you check all apples, so maybe there are 100 200 apples and you check one by one, or else you randomly check one from one box and one from another box and try to get that, okay, if that is actually been packed from the same particular batch of apple from the manufacturing unit, so probably it will be of similar in nature. If the apple is found to be rotten and 2 3 sample are actually indicating that the apples are not in good condition, so you can make a conclusion that, okay, this particular apple, the box of apples, they are not really of good quality. Even that is for any such kind of product, you can do it, you can taste it with certain amount of it. So by tasting it, you can get an impression what exactly it would be. So in many cases, when you go to a kirana shop or maybe in some other purchase, so say for example any food item, so before you purchase, many a times you taste, you go to a sweet shop and you want to procure, like say 5 kgs of that particular sweet. So in that case also, you just randomly taste that, okay, sweet type 1, sweet type 2, and then if you find, okay, the taste is good, so you go for accepting it that, okay, the entire thing will be good. So this is something called the tasting, or just tasting on a small subset of the target population, or you can say the entire thing. Now what is sampling in this? Definitely this is example with the watermelon, easy to understand that this is the entire, you can say that watermelon, and this is a very common question. Even if you ever purchase watermelon, always this question is in our mind, that whether it is all good, whether inside it is red or it is not. So in many a times, the seller, they can do a trick and they can just make some kind of tapping on this and can say that, okay, this is probably the good one, if you cut it, you will get the red portion, it is absolutely okay. But at the same time, many a times you don't have the faith on the word that the seller is telling. So in that case, we always ask that, okay, maybe can you show it? So in that case, definitely the seller is taking a chunk of it and then show that, okay, this is as per your requirement, it is quite red, and then you can trust on that, okay, if this is red, so the entire watermelon will be red. So this is the way that a small portion of the population that gives information about the entire population is basically the sample, right? So let us go ahead with that. Say for example, why to do sample? So what's wrong to take all the population into account? First of all, it is very difficult, because in such cases you cannot like take response of so many people if your study is based on that. So here we are giving one example, that is that suppose you consider you want to understand the behavior of metro user in Delhi, right? So like their perception towards the metro ride and the comfort and other aspect. So in that case, suppose you also need data on the age, gender, their origin, destination, and then other their income level and their perception and experience related data, experience related to the service quality of the metro. So in this case, the average daily ridership in metro is about 5.5 to 6 million. So that means 1 million is equal to 10 lakhs. So each day it is about 55 to 60 lakhs passenger in Delhi metro. Now can you able to survey all of them? Definitely, if I say answer no, you can't do the entire survey, so that is wrong. Theoretically that is wrong, because you can do that, but for that you need time, you need resources, you need more manpower, so that we can tap the entire metro rider, okay, or metro passengers to get surveyed through your questionnaire. But that is something seems little impractical in terms of investment of time, human resources, and the cost as well. So for that we can think of taking a subset of those. Maybe the selection may be random or it may be judgmental, that we will discuss in detail about the typology of sampling, but we can take out a subset of the total metro passenger as a sample and try to understand their experience or their perception towards the service quality of metro, which will convey the overall perception of the entire metro passenger. So maybe in that case our assumption is that whosoever we are going to ask the question as a sample respondent will represent the entire community. Now, why to sample? Definitely, it is practically impossible to survey the whole population. So, say metro population is 50 lakhs. If I want to do some study on the entire country population, it is in crore. So, probably it will be impractical for a research point of view. Now, for such kind of cases, if you want to tap each and everybody, so normally we do it in census, and that is a huge event. Lot many surveyors are involved into it. It's a door to door data collection. Each and every detail of all the household members, their information are captured in that census, and then definitely it is very much cost intensive. So for that, definitely in order to save time and cost, mainly we go for sampling and we try to determine the sample. Now next question is that how large should be the small portion? So to check and understand the watermelon, what it exactly, should we take a small portion of it, or we go for 1/4 of it, or we just need to go for half of it, or maybe 3/4 of it? So in all cases it is not the whole one, it is the part of it, but how much is adequate? So this is something really common questions, that what should be that sample size. Now definitely in this case the question arises, what size of sample gives adequate and reliable information about the population. If it is too much, almost close to, like if we take this particular example like D to assess the quality of the watermelon, so almost we are covering the entire watermelon, right? Only 1/4 is left out. But if we only go for this one, which is almost probably the 1/8 portion of this watermelon, and then if it can solve or it can convey the overall taste, quality and appearance in terms of color and all for the watermelon, so probably we'll go for 1/8 rather than going for the 3/4 option, because in this case that you can taste very quickly, easily, without wasting much resources. So in this case what is happening, say for example a watermelon is not properly uh, you know grown. So in such cases, if you just take out a small portion and you find that still it is requiring some time, 1 day time, still you can put it into some of the container, or maybe in some location, and you can further use it. So in that case it is not totally wasted. But if you take and you just keep on tasting it for a larger amount of the entire watermelon, and then you find that okay, it will take some time to get into the proper shape and taste, so then probably that will be the wastage. Now definitely determining the sample size is not very easy, and it will also depend on the experiment. So for that we have to refer the thumb rules of your discipline, which may vary from medical discipline to the social science. So in social science, if you go for some market survey or some kind of perception survey, so the sample will be little more, because it is comparing certain kind of population as a large, where there are so much of heterogeneity, you can expect that kind of variation in the answers. Now I am giving you some in-depth idea on this, why we are asking more than one person in case of a social science research or a perception or experience based research, because we assume that based on the age, based on the gender, based on the income level, the idea or the perception may change. And after certain sample, if you can tap the adequate number, okay, so then next person will say similar. Suppose you ask 10 respondent who are like female, and they are at the age group of say 19 to 25, and their perception towards certain kind of attribute, it is almost same. So the next one you can predict that probably another female respondent having the age of 19 to 25 will also make similar kind of judgment. So that's why probably we need to make it like in that way. But at the same time, if it is only for that age group, so what about other age group? Is it like the a female respondent having age more than 50 will differ from the same experience being shared by a respondent, female respondent aging like 19 to 25? So for that things are more in terms of uh, showing the heterogeneity. But in terms of medical science and other things, suppose you are making a medicine and it is some kind of chemical reaction that you are observing, so in that case probably the sampling can be little lower. But again it's not very straightforward that how many trials that you need to make to get into that particular conclusion. Sometimes it may be like even in thousands, even 2000s trials that you need to make to fine tune that particular result that you want, because it's testing and testing and testing will give you some confidence of the replicability, that okay, each time you are going, so there is some sort of 99% success that you are getting. It's not that one you are getting 99% success and then in some other experiment the same kind of composition will give you 80%. So then there will be a question of reliability. Now, as already it is being mentioned that it will vary depending on case to case. Say if I want to do some kind of experiment, say I want to measure the cognitive ability of any respondent towards say walking. So while walking, so what they navigate like through their eye tracking and other thing, if you want to navigate, so in that case definitely our psychology or our eye movement on a road may be not much varied like their opinion, because it is something like which is about reading the eye movement, or maybe if we apply some sort of device to measure their heart rate variability, or maybe their brain signals to take a decision on how to navigate. So in all such cases definitely you may not require a huge sample, because in that case the variation in response will be less. So whenever you expect that there will be variation in answers, you need to increase the number of sample, which is a case for when you go for some kind of experience or perception study, because perception may vary man to man, but their scientific response to an environment will be almost same, right? So the decision will be almost same, where we just react to a particular problem. So now in this case some of the established formulas are there. So here I will show you the Cochrane's formula by which you can calculate the sample. We take up the same example about the sample size, where the metro users, daily metro users is about 55 to 60 lakhs. Then what should be the minimum sample size from which we can get the information about the metro experience? So here we go with this formula. So where n0 is the initial sample size, and in this case where the sample like population is unknown to us, we do not know the total population, then also we need to go for sampling, then we can use it where there are certain parameters that you need to know. One is the z. So this z value is coming from the z table, and this is showing the confidence level of that particular selection. Like maximum it will cover all this variation and nothing will be covered with that. So normally we do this calculation at 95% confidence interval, and that is something, the z value, corresponding z value is 1.96. So then 1.96 will be replaced with this g. Then we have another important aspect at denominator of this equation, that is your margin of error. So in this case margin of error is normally taken as 5%, But at the same time, you can also, depending on the accuracy, as because it is in denominator, so if you increase this particular value, okay, so then you will see the result, there is a change. So if you want much more error, so your sample size will be reduced, as because it is in denominator. But if you have something like, you lower down the margin of error, so 5% you can make it say 1%, so your numerator will remain constant in that case, and then your required value for n will increase. Now P is a very interesting aspect into it, which is called the population proportion. So P is the probability of the attribute you are looking for. For example, a random metro passenger you are going to survey is female. So we don't know the mix. So male, female, they are the passengers. So if you are interested to observe or tap the experience or of female passenger towards the metro facility, so in that case, then we can take up that, okay, for this particular character that our sample should be the female, what could be the probability. So in that case, 0.5 is taken as where you have no other characteristics available. So if you know in a particular population that it is 30% female that is there and 70% is male, and you want a equivalent distribution among them, so probably in that case you are going to take the p value as 3 and 7, where your intention is to tap this particular female respondent. As because you have p and also 1 minus p, the total is 1. So whatever value you are going to take, so you also have this multiplied. So in this case, other important part, that if you take the value of p, the population proportion, as 0.5, it can give you the best and maximum product result of this equation, p into 1 minus p. Say for example, if it is 0.5, so it will be 0.5 into 0.5. So this will give you 0.25. If you take any other value than this, where the p can range from 0 to 1, so then it will be lower than 0.25. Say for example, you make it 0.6, 0.4, so it will be 0.25. You take 0.8, 0.2, then you will also get 0.16. So in that case, in order to capture the maximum heterogeneity or the proportion into the equation, so 0.5 is what is giving you the better result or maximum result. So with this, if you calculate, so we will end up with certain minimum sample size. So in this case, definitely we are not adding any information about the total population, that is, if we know that total population is 55 to 60 lakhs passenger. Now this is something, so based on that, if we put the value 1.96 into this, then 0.5 as a proportion, and then this is the 5% error, we convert into a decimal, so 0.05. So it will give you 384.16, so almost equivalent to 384. So this 384 sample is for infinite population, because there is no such parameter involved in this equation which is talking about the population. Now this is generally being used, but remember, this is minimum sample size where we do not have any other intention to do with this sample. Say for example, if you want to capture the passenger's experience, so this 384 is okay when you go for an aggregate level analysis. We are not going to again break this entire sample into smaller group like age wise or maybe gender wise. Then probably if you want to capture say 3 different levels, like say age group 1, age group 2, age group 3, so then your sample size should be more than that, because to represent that age group 1 you should have at least this much of sample out of the population if population is unknown. Or else if you know proper proportion that okay, in a particular population there are 30% people belong to age group 1, then 30% age group 2 and 40% age group 3. then accordingly the sample can also vary. Now, if we know the population, so let us assume that we have say around this many passenger, where you have 50 lakh passenger, 5 million passengers. So then how we can modify our initial sample size, which is n0. So here we calculate it like this. So where it is the total, like final sample size small n equals to n0 divided by 1 plus n0 minus 1 by n. So this capital N is the total population. So if you do it, so you will end up with a population which is 383.97. So you may argue that okay, what is, again if you can make it like a whole number, it will be 384. So why we require to do this? So look at it, as because 50 lakhs population is also huge number, that is why it is very close to the 384, but it is not exactly 384. In previous calculation we have seen it, it is 384.16, and then in this case it is lower than that. Even if it is fractional, statistically it is lower than 384, right? Even if it is lower than 0.25, statistically it is lower than that. So that means if you lower down this passenger, so the sample size requirement will also lower down from that aspect. So say for example in terms of 50 lakhs population, if you make it only 5,000, so in that calculation you will get 357. But you can say that from this to this level, the population or the sample requirement is not changed in the same pattern. So yes, obvious, whenever you have very smaller size of population, so sample will be as close as your population. Say for example in a particular class there are 5 person. So in that case what could be the sample size? So for 5, if you apply this formula, probably it will give you 3 or 3.5. But when you increase it to 50, so it will be not directly proportionate to that, it is not in that same ratio. So with this formula you can always calculate it, but remember one thing, so whatever 384, 357, that is the minimum size that we are calculating through this formula, it is with a objective that okay, the entire sample will have a similar kind of testing, or maybe the analysis will be done in a similar way. It is not bifurcating the sample further to distinguish it. So in that case you have to increase the number, and probably if you take say 2 parameters to be measured like male and female, and they are also having the equal presence in the population, so this will be probably 384 into 2, the minimum one, and you can go to little higher number. Why it is required? Because when you are doing the survey with the sample, targeted sample, you may come up with certain respondent which are like incomplete, and probably in that case you cannot take those kind of respondent into that data analysis. So there will be some removal. So earlier class we discussed about this as well, the data refinement stage. So at this stage probably we have to discard some of them. So ideally if you go for this kind of 350 as like required minimum requirement, you should go at least 10 to 20% extra, so that at least after refinement you can get into this particular number. If all the responses are in correct order, so it is always good, because this is the minimum number. It is not like it is the number that you can also lower it down. So for the sample size to be the representative of the entire population, so we need to have this much of sample anyhow. Now why adequate sample size is important? So in this aspect definitely it should represent the population, and for that whatever sample is required you need to do. Reliability of the collected data. So that is why I am saying if my sample data collection is not representative of the population, so always question will be there, the overall information is not being captured adequately. There might be some different in opinion which is not represented through your population. effective use of financial resources, because if you go for higher number, so too much you don't know, you just go for 80% sample of a population, so which may not be required for your study. Wherever it is required to be tested each and every person, so that is a different thing. So that is again some sort of, you can say that, the mass scale sampling may be required sometimes, at times that, if you have one suspect, then probably you go for testing. So if you recall, again I am giving this particular example which you can relate well, that early days of your COVID-19 phase, that there was certain test that has been prescribed, that is the RT-PCR test. So for that, how it goes, like initially when there was certain kind of positive that found in a locality and all, so then there was certain kind of emphasis on go for some kind of random testing. So each household or maybe each flat there is some random test, and if there is some kind of positive case, then probably again the entire family to be tested. So it is something again, some sort of strategy that has been made. If, obviously at that particular time government could think of, testing each and everybody. So finally the issue was that there were not enough kind of, testing material available to test some, crore and crore population. So in that case it was much more on the initial sample basis, and then based on that, it is, if required, it can go for the entire family to get tested. So similarly for your study, if you find that there are so much of variability and you want to capture the variability, you want to study the heterogeneous behavior of people in terms of their age, gender, or maybe income towards certain kind of, facility, or towards certain kind of opinion. So in that case you have to enlarge, you have to increase your sample size based on that. Estimate the time required for data collection. So the moment you know that okay, I need to collect say 400 odd samples, so each sample, if it's depend on the number of questions that you ask, the type of questions that you ask, and the complexity in answering it, you can assess that per sample this much of time is required. So you can calculate the total amount of time you need to devote for collecting the sample, and in that case again this is one part of making the minimum sample size calculation. But at the same time, when you go for such kind of interview or maybe the human participation in those kind of survey, it is not always true that you approach a person and automatically he or she will agree to answer you. So there is some important aspect that is called the response rate. So in many cases you will find that people are not interested. So in that case, if you approach 5% and then probably you only could able to get one response, and maybe next case you go for 10 people and you get one response, so automatically your response rate will be less. If it is 100%, so definitely time will be, the time requirement will be less in terms of even approaching, even intercepting. But in general, for such kind of study, especially in India, the response rate varies as low as like from 30% to 50% in some cases. If it is more than that, so you feel yourself lucky that okay, people are taking part into it. And always like this number, even the range that I am saying about the response rate, it will also depend on the type of survey that you are doing, how much interesting it is to the respondent. If it is too much technical, people even will show the interest initially, and after answering one or two questions will go away. If this is something of some interest, then maybe you can get more responses, and then that can go very easily in a smooth way. Now sample survey in urban planning, this is the context. So definitely survey analysis and plan. So you have to first do the survey, whatever information that you need to collect, then you have to analyze it and accordingly plan it. So based on that responses, if you go for certain approaches or giving some sort of strategy, it will have some kind of acceptability because you have taken the people in confidence. Now the sample data is required for preparation of any comprehensive development plan. This is one example. Then the data will be something all on the housing, it can be transport, physical services like water supply, sanitation, etc., other social services and other amenities. So those are the informations you can collect. We'll discuss that type of surveys in other lecture. We have discussed already that in that case, like for household survey, like definitely what are the things normally we ask. If it is a transportation survey, so if you go for a origin destination survey, so we discussed that in our previous discussion, and based on that definitely you can assess the need of determining the sample in that case. So it's not like going for entire population like census, but sample, a representative sample is also worth of representing the entire population. The sample must be chosen scientifically with certain methods. It may be something on, you can say that we go for some kind of random sampling, or we may go for some kind of purposive sampling. So all such kind of random sampling, purposive sampling and other type of sampling we will discuss in the follow up lecture. The method of sampling and size of sample will vary case to case and should be determined carefully. So as I already mentioned, when there is less variability, like say for eye tracking type of research where you just try to see visually or through eye movement how people are navigating the environment, the urban design features. So in that case probably you don't need to go for that high number of sample, because the variability in the response, the retina response is not that much, rather than giving an opinion or experience hearing. So for that it would be less. Sometimes if you do this experiment in the laboratory by testing with certain kind of device and measure some kind of body vitals about the heart rate variability, or maybe you can capture some other information, in that case the brain signals and all, probably it can also as low as say a 15 sample, right? So like that you have to take a call on it. So what I have shown through that formula, it is much more on the larger sample side when you go for some kind of perception based survey, right? So with that, let us summarize in this whole presentation. So we understood what is sample and why to sample, what is the need of sample size in the research in planning and architecture, and also I have discussed you the sample size calculation for one type of research. But again the disclaimer is that the sample size and the sampling technique will depend on the research, whether it is experiment based research, where it is perception based research. Wherever there is more variability in the population and you want to capture all of them, you have to increase the number. When the variability is less, then probably it can also be okay with the lower number of sample, and for that definitely you can get a clue when you go through a number of papers. So that's why I always keep on telling that the need of doing a very good literature review is this also, like where you can understand about the sample size that the other study they have considered, because in that case you can also understand through their write up that what were the challenges with that huge number of sample or the small number of sample, right? And then that way you can get enough insight. Okay, so hope this is clear to you, and with that we end up this particular lecture, and we'll be meeting again to discuss another important aspect related to the sample, that is the sampling technique. So we'll be discussing this in two parts. So one part will be on the non-probabilistic sampling, which will be the sampling technique part 1 in lecture number 22, and also we'll be discussing the probabilistic sampling and what are the different types in next lecture, that will be lecture number 23. So with that, thank you once again for joining the course. Hope all this information and discussion are helping you in a great way. So we'll be meeting with you in the next lecture, which is on sampling technique part 1. Thank you.